Hello everyone. In this class, we will learn about the classification and structural characteristics of the wind power generation systems. Next, we will learn about the classification and structural characteristics of wind turbines. According to the direction of the rotation axis of wind turbines, they can be classified into the horizontal axis wind turbines and the vertical axis wind turbines. The figure shows a horizontal axis wind turbine where the rotation axis of the wind turbine is parallel to the wind direction or the ground, and the impeller needs to adjust its position according to the wind direction. This is called the horizontal axis wind turbine. As shown in the left figure, the blades of the horizontal axis wind turbine have a large rotation space, high rotational speed, simple structure, and higher efficiency than those of the vertical axis wind turbine. The figure shows a vertical axis wind turbine where the rotation axis of the wind turbine is perpendicular to the ground or the direction of the airflow. This is called the vertical axis wind turbine. The wind turbine of the vertical axis wind turbine rotates around a vertical axis, and its main advantage is that it can accept wind from any direction. The disadvantage is that it has a large starting torque, which provides relatively low power output when the size, quality, and cost of the wind turbine are constant. According to the direction in which the wind turbines receive wind, the wind turbines can be divided into the upwind wind turbines and the downwind wind turbines. The left image shows an upwind wind turbine where the wind first passes through the wind blades and then through the wind turbine of the tower. This is called the upwind wind turbines. The upwind turbines has an anti-wind device that can rotate with changes in wind direction. The right image shows a downwind wind turbine, where the wind first passes through the tower and then through the wind turbines of the rotor. This is called the downwind wind turbines. A portion of the air in the downwind wind turbine passes through the tower and then blows towards the impeller, causing the tower to interfere with airflow passing through the blades, resulting in a lower coefficient for wind energy utilization. Therefore, the downwind wind turbines are currently rarely used. According to the connection method between the blades and the hub, the wind turbines can be divided into the fixed-pitch wind turbines and the variable-pitch wind turbines. The connection between the blades and the hub of a fixed-pitch wind turbine is fixed. The variable-pitch wind turbine is equipped with a variable-pitch system inside the hub, which can adjust angle of the blades facing with the wind direction. The variable pitch system has the functions of variable pitch, braking, and impact-free grid connection. According to the control method of rotational speed of the wind turbines can be divided into the CSCF wind turbines and the VSCF wind turbines. The rotational speed of wind turbines includes: first, constant speed. Second, polyvariant constant speed. Third, variable speed. A constant speed wind turbine is defined as the output of wind energy that does not change with the magnitude of the wind speed when the rotational speed of the generator remains constant. Polyvariant constant speed usually refers to the need to switch different power and number of wind turbines into operating mode, according to the continuous change of the rotational speed when there are two or more wind turbines. Variable speed refers to the situation where the rotational speed changes with the wind speed during the operation of a generator. Due to the low mechanical stress, low cost, and high efficiency of this type of wind turbine group, the mainstream large wind turbines adopt the VSCF operating mode, classified by the mechanical connection method of power transmission. First, gearbox-type wind turbines. The gearbox transmits the power generated by the wind energy, passing through the wind turbine to the generator, and then converts it into the corresponding rotational speed. Due to the limitations of diameter and wind energy, the rotational speed of the wind turbine is usually very low and cannot meet the performance indicators of the generator for normal power generation. Therefore, the method of adding a gearbox is adopted. Currently, the commonly used wind turbines of these types include the doubly fed induction generators, the semi-direct drive wind turbines, the high-speed synchronous wind turbines, and the high-speed squirrel cage wind turbines. Second, direct drive wind turbines without gearboxes adopt multi-stage synchronous generators, which can eliminate the common transmission system and allow the wind turbine to directly drive the rotor of the generator to operate. At low speeds, there are no problems such as noise, high failure rates, and high maintenance costs caused by the transmission system, improving the operational reliability. The modern large-scale grid-connected wind turbines have always aimed to improve the utilization of wind energy and reduces costs for power generation in the past few decades. By now, many types and styles of wind turbines have been designed and developed. With the advancement of the science and technology, the structural form of the units is increasingly inclined towards the horizontal axis. Third, the current development trends of wind turbine technology, such as blades and variable torque, include the continuous increase of the capacity of the single unit of wind turbines, the development from the fixed pitch to the variable pitch units, and the development from the fixed rotational speed to the variable speed units. Direct drive full power convert technology has rapidly developed, and the performance and control technology of key components have gradually improved. The technology of offshore wind power generation is developing rapidly. In this lesson, we have learned about the classification and structural characteristics of wind power generation systems. That's all. Thank you for watching.